So we're going to factor a difference of squares, difference of cubes, and a sum of cubes. And we'll start out with the difference of squares formula. So if we have something in the form of a squared minus b squared, we know that it's going to factor into a plus b multiplied by a minus b, where the a comes from the square root of the first, and the b comes from the square root of, well, the second term, except not looking at its sign. You know, the sign is going to be handled with a plus or minus. So what we have is we have a binomial here, which is a difference of squares. And the first is obvious, and it's already written as something squared. So this is x squared. So we can see that a is x. But we know that 16 can be written as 4 squared. So we can see that b is 4. So now we know this factors into a being x and b being equal to 4. So, you know, a will be x, b will be 4, a will be x, b will be 4. So this is going to factor x plus 4 times x minus 4. Now, just kind of verification that this works is we can always just, we can always check it. And what's really interesting is this x squared minus 16 really is kind of like a trinomial where you have that center term equal to 0. So x squared plus 0x minus 16. So what you're really looking for is you're looking for two factors that multiply to x squared. Well, that'd be an x and x. And I need two factors that are going to multiply to negative 16, but they have to add to 0. So that's how that works. You have a negative 4 and a positive 4 will multiply to negative 16, but add to that 0, these being the same. So we really just kind of rely on our formula because this comes up so often. So I'll pop another example in here. So what if I want to factor 4x squared minus 9? So it looks like this is a perfect square, and I can rewrite this as something squared. So 2 squared is 4, and x squared would be x squared. So this would become 4x squared. And then 9 can be written as, our 3 squared. So we can see that this would be equal to a, and this would be equal to b. So our 2x is our a, our b is 3, so 2x and 3 here. So this is going to factor to 2x plus 3 times 2x minus 3. I have one more that I want to factor completely to where once you get to this spot, you might have to factor again. So if I want to factor 16x to the 4th minus 81, I can see that I can rewrite these things as perfect squares. So this is going to be equal to, well, the square root of 16 is going to be 4. Whatever squared gives us to a 4th power is going to be an x squared. And then 81 is 9 squared. So, this is going to be our a and this is going to be our b. So this thing is going to factor to 4x squared plus 9 times 4x squared minus 9. Now there is a formula for a difference of squares, but there's not a formula for a sum of squares. And the reason why is you get complex coefficients here. You get I back. So the difference of squares gives you real valued terms. So this thing is still factorable in real numbers as opposed to this one not being. So this is going to be a 4x squared plus 9. Wait till your pre-calc class before we start factoring this. Now again, this is a difference of squares. This is a 2x squared. This is a 3 squared. So this is going to be 2x plus 3 times 2x minus 3. So you just had an extra step in it because your resultant second binomial was a difference of squares. So now we have another formula for a difference of cubes, and actually what's interesting is there is another formula for a sum of cubes. So even though there's not a formula right now for a sum of squares, there is going to be a difference and sum of cubes. So I'll put the formula up here and we'll do some examples. So the formula for the sum and difference of cubes are written this way. So a cubed plus b cubed is a plus b, a squared minus ab plus b squared. And the difference of cubes looks very, very similar, except it starts with a minus b, and instead of this being a minus, this is going to be a plus. So that's how I was able to memorize these. Is the a cubed plus b cubed is going to start with a plus and end with and the next one's going to be a minus, and the last is always going to be plus. And then the difference is going to be a minus b will be minus, and then the next one's going to be a plus. When you get into log division of polynomials, we'll actually prove this difference of squares and difference of cubes and sum of cubes formula. Okay, so what I want to do is I want to factor this difference of cubes here. So I know that these things are both written as something cubed, so I really have to figure out what a and b are for each one of these. Well, this is already cubed, so that means x is going to be my a minus this is something cubed as well, and 3 cubed is 27. So I can see that this is the difference of cubes. Let's just do a sum here. This is the difference of cubes, and I know a difference. This is going to be x is a, b is 3. X is a, b is 3. And then just filling those out, so this is going to be a minus b, so this is going to be equal to x minus 3, multiplied by, well, a is x, so this is going to become a squared or x squared, plus a times b, so x times 3 is going to be the same as 3 times x. And then last is going to be b is 3, so this is going to be 3 squared, so this is going to be plus 9. So that's how you factor that difference of squares. Now this trinomial, we know that how to factor trinomials in previous videos, but I've only factored trinomials that have real number terms as far as its factors. And this trinomial will not be factorable in real numbers. It is only factorable in the complex. So we'll get to those as well. So right now we consider this prime because it's not factorable over the real numbers. Now this is a sum of cubes. So in order to figure out a sum of cubes, I know that this thing can be written as something cubed. So this is something to the third power. So 2 cubed is 8, and y cubed is y cubed. So your a is going to be your 2y. And then your 64 is plus, well, this is going to be 4 cubed. 4 times 4 times 4 is 64. So this is going to be your a, and this is going to be your b. So a is going to be 2y, b is going to be 4. A is going to be 2y. Don't forget, you still have to square it. So this is going to be 2y, and b is going to be 4, and b is also still 4. Okay, so this is going to be equal to a plus b. So a plus b multiplied by a squared. So remember, I'm going to have to square this. So 2 squared is 4, y squared is y squared. So this is going to be a 4y squared. And I'm going to have a times b, but opposite side, so minus. 2y times 4 is going to be an 8y. And then last is going to be a 4 squared, which is going to be a plus 16. Now, I chose this knowing that there is a greatest common factor here. You know, you could have factored out that 8, but what I wanted is I wanted to show you that you could have a a binomial factor here and another factor here. Notice that if you would have pulled out the 8, you would have had y cubed plus 8. So notice that this here is a 2 and this here is a 4. So you could still factor out that 2 and 4 to factor out that 8. So let's do that one instead that way, and then show you that we really get the exact same thing back. So we'll just say b again. So b, I know I can factor out that 8 and I'd get y cubed plus 8. Now the 8 is just our constant that sits out the front, so the sum of cubes is this binomial that's left over. So this is already written as something cubed, and I know that 8 is the same thing as 2 cubed. So this is going to be y cubed plus 2 cubed. So we're up here. A is y, b is 2. A is y, b is 2. So this is going to be 8 times a plus b, so y plus 2, multiplied by y squared, because it's a squared, times ab, but negative, so y times 2 is 2y. And then last is gonna be 2 squared, which is gonna be a plus 4. And I can prove that here, so if I factor the 2 out of this term, you get y plus 2. If I factor the 4 out of this term, you're gonna get y squared minus 2y plus 4. And then the 2 and the 4 become 8. Now we tend to like to do the greatest common factor first because it makes the numbers smaller, it makes them easier to factor.